Hi, myself Alfred Anthony and my co-authors are Austin Dennis, Srividya P. Menon and Binu Richu. I am here representing Federal Institute of Science and Technology, Mukanur, Kerala. I am here for presenting the paper on Indian Sign Language Interpreter, a portable device, on this 15th International Conference on Soft Computing and Pattern Recognition 2023. Our paper is titled is Indian Sign Language Interpreter, a portable device. As we all know, there's a huge communication gap between the deaf mute section of society and the normal section. And this is because the normal people cannot effectively understand the sign languages. As per the latest reports, WHO states that a total of around 34 million children all around the world has speech and hearing disabilities. And if we take the statistics of India alone, we can see that around 63 million people in India falls under this category, which amounts to around 6.3% of the entire population of India. Based on these needs and requirements, several works are being done presently in this area, but there are several drawbacks of the presently done works. I will mention what are the drawbacks of the presently done works in this Indian Sign Language or Sign Language interpretation. In Indian Sign Language, the interpretation or the integration of both hand and facial cues is very essential. Integration of both hand and facial cues are essential for ISL because facial expressions such as eyebrow movements, eye gaze, and mouth shapes convey critical grammatical information. For example, if two Indian Sign Language gestures are considered, if they have the same hand interpretation, what differs these two signs in ISL is the facial nuances that we consider. Therefore, integration of hand and facial cues is very essential in ISL interpretation. Also, current technologies lack the real-time sentence level conversion of dynamic ISL gestures. For efficient communication, we need to convert the ISL gestures on a real-time basis and also in a sentence level. Also, there is a lack of day-to-day user-friendly device that is available. So, how the device must be is that it must be a companion to the deaf mute section so that they can use it wherever they travel, wherever they need. So, based on these current scenarios, the deaf mute individuals face significant challenges in accessing education, healthcare, and employment due to the communication constraints leading to their social exclusion. There is also absence of comprehensive data sets for ISA. Based on the studies we did, we developed certain objectives for our work, and they are firstly, the multimodal integration of the facial cues and hand gestures for the nuanced communication. As I just stated, for effectively interpreting the Indian Sign Language, facial expressions play a key role. So we integrated hand and facial gestures together. Also, for the effective communication, the communication must be on a real-time and sentence level basis. So the real-time sentence level conversion of the sign languages was our second objective. Also, I mentioned that the availability of datasets in ISL is limited. So we developed a custom dataset with 4 different signers under different lighting conditions for attaining improved accuracy and generalization. We also focused on developing a compact user-friendly device for the use by all sections of the society, thereby enhance the accessibility in education, healthcare, and employment sectors. Based on these objectives, we came up with a compact device which can be used by the deaf mute section on a day-to-day basis like a companion device. So the ESP32 wireless camera module was used for capturing the real-time video of the deaf mute section of society. The frames from the captured real-time video was processed on Raspberry Pi 4B. Based on the model that is deployed on the Raspberry Pi 4B, this model outputted the Indian Sign Language conversion into text which was displayed on an LCD display, and concurrently this sign language was also converted into speech for the normal person to understand. Our developed model is a compact device and user-friendly device which is just like a mobile phone. We can easily carry it in our pockets or backpacks. Assume a person is traveling a deaf mute section society person is traveling in a bus or car. So he need to communicate with the common people. So he can easily take out the device from his backpack or pocket. It's a wearable device. He can wear it through his neck, and there is extendables that are provided which he can extend and effectively communicate the sign language with the normal people. And when not in use, he can easily keep it back in his pocket or backpack. So this is how we have implemented this system. Coming to the details of the dataset, so we utilized 4 different signers, and the dataset was custom made by ourselves, and the images were taken under varying lighting conditions for improved generalization. A total of 4,997 images were captured, which was divided into further 4,650 training datasets and 347 validation datasets. Data pre-processing techniques, including cleaning, normalization, and feature engineering was provided for improved model learning. Data augmentation techniques for rotations, flips, and brightness adjustments also expanded the dataset and prevented overfitting and enhanced the adaptability to unseen data. The classification accuracy for the low lighting conditioned images was increased by the use of data augmentation techniques. So this is explanation of the datasets that we have used. And initially, as an initial stage, we have implemented this on 5 datasets or 5 classes of Indian Sign Language. Coming to the software flow, the dataset is first undergone through the data pre-processing and augmentation, followed by 2 convolution 2D layers and a max pool layer, further passed to 2 convolution layers and max pool layers, then a dropout layer, a fully connected dense layer, and at last the prediction of the output. Coming into detail of the software flow, it was a sequential model with 2 initial 2D convolution layers with 16 filters each, using ReLU activation function for detecting the lower level features like edges and textures. Additionally, 2 conv2D layers also with 32 filters each, and max pooling layers were provided for extracting the more complex features from the images. A dropout layer with 20% rate was applied after the dense layer to prevent the overfitting and improve the generalization. Softmax activation as well as ADAM optimization was used for model optimization during training. Coming to the details of the results, initially on the training dataset, we attained an accuracy of 97.7%. But on the real-time data collection or the real-time prediction, the data accuracy or the prediction accuracy dropped significantly to 87%. And we identified the problem as the model's lack of generalization capability. So further experiments were done and better activation functions such as ReLU and ADAM optimizers were used for best performances. Also, we came to know that the lack was in the generalization. So we used data augmentation techniques to enhance the generalization. And after the usage of data generalization techniques, we attained an improved accuracy of 97% on real-time data or real-time Indian Sign Language prediction. The model size was optimized for the deployment on Raspberry Pi 4 without compromising any accuracy. So here we have implemented this on 5 class problem, and also the developed device is only the first prototype. So in our future works, we are focusing on implementing this system for an enhanced Indian Sign Language dataset so that the entire Indian Sign Language can be interpreted using this device. Also, our focus was mainly that any section of society can use it irrespective of where they are or what they are doing. Even if they are in an educational institution or if they are on a travel, whenever they need to communicate with the common people, they can easily use this device. So our focus will be to implement this as a user-friendly compact pocket device so that they can use it like a smartphone. They can carry it in their pockets or backpacks. Whenever they need to use it, they can take it out It's a wearable device. They can wear it and extend out the displays, speakers, and other hardwares that are provided. And using these extendables, they can easily communicate with the normal people. And when they are not in use, they can easily take out the extendables and keep it back in the backpack or pockets. So in the future works, we will be implementing this system as a better one so that any people in India can effectively use this device to communicate with normal people so that the communication barrier that is present between the normal section of society and the deaf mute section of society can be effectively reduced. So, this is all about our work, and thank you.